Okay, so the last topic we'll be talking about in calculus is optimization, using derivatives to figure out what the optimal solution is, what the best answer is, which is pretty cool. And this is actually a very useful thing that calculus is used for. So I'll do some examples here, like the ones in the homework. I suggest you do numbers 3 through 23 odd, so you can check your answers in the back. And I'll do some similar ones here to get you going. I did some at the Zoom meeting too, so hopefully these make sense. Okay, I'll do number 2, and this is all on page 311 here. And then number 3 is similar. It says find two numbers whose difference is 100 and whose product is a minimum. Okay, so let's say the difference is 100, so let's call them A and B for, call them whatever you want, but let's use A and B. So difference is 100. So let's say A is the bigger one. So A minus B is 100. So A is 100 bigger. The difference between them is 100. And then their product is a minimum. So AB equals their product. We got to call that something. Let's call that Y. I don't know. So their product is Y, and we want it. What numbers have a difference of 100 and their product is a minimum? Okay, so what we want is a formula. We want to find the derivative of y, and so y is AB is that formula, and we want to find AB, the smallest AB possible, but this has to be true. So what we got to do is solve for A or B here, plug it into here, and take the derivative with respect to that variable, and then solve for it. So let's say we solve for A here. So A is equal to 100 plus B, right? Just put the B on the other side, plug that into here. So 100 plus B, let's put the Y first. Y is equal to A, which is 100 plus B, times B. That's easy math. So we have Y is equal to 100B plus B squared. Now we want to minimize that. We want to take the derivative of y. This is what we want, the product, right? Y is the product. We want it to be the minimum possible. So we do dy db, take the derivative with respect to b, which is easy. That's what, 100, yes, 100 plus 2b, b squared is 2b, set equal to 0. And then we can find out what b is. So let's see, 2b is equal to, yeah, so 2b is equal to negative 100, and therefore b is, divide that by 2, b is negative 50. Okay, we know what one of the numbers is. Well, let's see, a is 100 plus b, so a is 100 plus b, which is 100 plus negative 50, which is 50. So the two numbers who are furthest away by 100, so A is 50 here, are 50 and negative 50. So their product is a minimum, because their product is going to be negative, right? Negative is a minimum, is smallest. That's what 50 times 50 is. Let's see, 25, 2 zeros, negative the 2,500, and they're 100 apart. Negative 50 is 100 apart from 50. So those are two numbers. Now we could have guessed that. That was kind of tricky, the negative part and everything. But you know, we could probably have guessed that. But here we don't have to guess. We can just solve it. It's pretty easy derivatives, pretty easy math, and we can actually get a solution. Okay, so number 3 is very similar to that. So yes, so the other ones are kind of like this. You know, you come up with the formulas for things. Let's do number 6. So there's a similar example. Number 6 says the dimensions of a rectangle with area 1,000 meters squared whose perimeter is as small as possible. So we have a rectangle, it's 1,000 meters squared. We got to name them, so again, let's call a side A and B. And its perimeter is as small as possible. We want to minimize the perimeter, so let's call that Y, or we could call it P, call it whatever you like. Let's call it P, so we know what we're talking about. So the perimeter is it's all the way around, right? So it's 2a plus 2b. 2a's, one here, and then 2b's, right? Because this is b, this is a. So 2a plus 2b. We want to take the derivative of this, set it equal to 0. But we have an a and a b. We got to get rid of one of them. And the other thing we know is the area is 1,000 meters squared. So area is a times b is 1,000. We can solve for either one. Plug it into here. Let's solve for a. Why not? A is equal to 1,000 divided by b. Plug that into here. So the perimeter is 2 times 1,000 divided by b plus 2b. Or do that math. That's what? So the perimeter is 2,000 over b. Let's write that 2,000 b to minus 1 because that's easier to take the derivative of because the b is in the bottom. So 2,000 b to the negative 1 plus 2b. Take the derivative with respect to b, we find out what b gives us the smallest, and then we can figure out what a, because a is 1,000 divided by b. Okay, so dp db, b to the negative 1 is negative 2,000, b to the negative 2, derivative of 2b is just 2. Set that equal to 0. And then solve for b. So let's see, this is, I'm going to go up to here to do this now. Negative 2,000, b to the negative 2. Let's put the negative 2 over there. So that's negative 2,000 divided by b squared equals negative 2. I think that's right here. So just put the 2 over here, make it negative. Now they're both negative, so we can make them positive. Let's see, let's swap the b squared into 2. One's in the bottom, one's in the top. We can do that. So b squared is equal to 2,000 over 2, which is clearly 1,000. Or so b is equal to the square root of 1,000. We could leave it like that or get a number out of it. Square root of 1,000 is 31.6, goes on forever. So let's just say 31.62. Sure, I'll put a 2 there. 31.62. Okay, a is 1,000 divided by b. So a is 1,000 divided by b, which is 1,000 divided by that. And that is going to be the same thing, it looks like. Which makes sense. So a is the same thing, 31.62. So it should be a square. Both sides are the same. Both sides are 31.62. So it looks like if we want to minimize the perimeter, the best shape is a square, which kind of makes sense. We could have guessed that. But now we proved it. There is no funny rectangle. The best shape is a square. They both have the same sides. Okay, so that's how you do that one. Let's do a few more examples since this is so much fun. I think these are fun. I mean, this is like a puzzle. Try to figure these things out. It's kind of cool. Let's look at number 18. It says that find the area of the largest rectangle that can be inscribed in the ellipse x squared over a squared plus y squared over b squared equals 1. Okay, so x squared over a squared plus y squared over b squared is equal to 1. Okay, now we're getting tricky, right? This is not so easy. So what this is an ellipse. And the center, if you remember, circles are x squared plus y squared equals 1. That would be our perfect circle of radius 1. This is a circle of radius 1, but the a stretches it. The easy way to write this, better way to write it is x over a squared plus y over b squared is equal to 1. So we take a circle of radius 1, and it's centered at the origin since we don't have x minus 3 and y minus 2 or something. So this thing is centered at the origin. That's nice. And it looks like this. And a is the x direction. It tells us how much bigger than 1 this distance is. The radius is in this direction. And b tells us how much bigger than 1 or smaller than 1. If a is 2, then this would be 2. If a is smaller than 2, it makes it smaller than 1. And b tells us the y dimension, how much bigger it is. It's just stretching it, right? If you divide the y by a big number, it ends up making it bigger. We learned all that stuff in pre-calc, how to stretch things. Okay, so we want to put a rectangle in here. Okay, so that's what I mean by inscribed. You want a rectangle in there, and it says, again, the problem says that find the area of the largest rectangle that can be inscribed in this thing. What is the largest rectangle that can fit in there? Okay, well, this looks kind of tricky. So what are the dimensions of this rectangle? So the largest rectangle, area of the largest rectangle. Okay, so we need to call the sides of our rectangle something right now. Here's the deal. By symmetry, we just need to choose one of these little rectangles. And then if that's the biggest, then, because they're all four going to be exactly the same, because this is a perfectly symmetrical thing. So all we got to do is find the area of one of them, not like they're the whole thing, and then multiply by 4. Okay, so that's one way to do it. So let's choose like this one right here. Now remember, A goes all the way to here. So its dimensions here are not A. Let's call its dimensions X and Y. Why not? So the area of our rectangle is 4xy. The area of the entire thing is 4 times, right, X and Y of this point's here. So here's X, here's Y. The area is 4xy. Okay, that's all good, but we got to get rid of one of those things here, right? We want to take the derivative of the area, set it equal to 0 to kind of find the biggest area. But again, we have an x and a y, and the trick for all these is you always have two ways. You always have at least two formulas, and you use one of them to get rid of one of the variables. So you can take the derivative with only one of them, either x or y. And we have this formula here, so we can use this to get rid of one of them. So we can like solve for y, plug it in here, have only x's. And it looks like it's going to be a mess. But that's why we take calculus, to get good at this stuff. So let's solve for y then and plug it into here. Okay, so we start over here, so I'm going to do a bunch of algebra now. So this is our basic formula. Now we got to do our solving for y. So we use this formula, so y squared over b squared is equal to 1 minus x squared over a squared. Multiply everything by b squared. Y squared is equal to, let's see, 1 becomes b squared minus b squared x squared over a squared. That gets rid of the b squared in the bottom here. Everything's by b squared, yep. And then y is the square root of that. So y is the square root of all this stuff. Now I could have we could put the b in the outside. I could have taken the square root here and then be b in the outside times all that. I wonder if that would be easier. Yeah, that might be easier. I don't know. So b squared minus b squared x squared over a squared. And again, we have a b squared inside, so maybe I should have done that. So let's just write it like this. B times the square root of 1 minus x squared over a squared. That's probably the best way to write it. So that's what y is. Now it's plus or minus, but we want a positive y. We're talking area here. That's why I just took the plus here. We don't need the minus because we just want a positive dimension for our area. Okay, plug that into our formula. A equals 4xy. Now area equals 4x times y, which is this, which is b times the square root of 1 minus x squared over a squared. Okay, b is a constant, 4 is a constant, x is not. We got to take the derivative of this now. And we take a deep breath, it's not so bad. We're going to have to use a product rule because we have this times this, so the derivative of the first times the second plus the first times the second. So derivative of 4xb is just 4b, right, because the x goes away, times the second, which is this, 1 minus x squared over a squared, plus 4xb, I'm going to put the x last, 4bx, times the derivative of the square root. So that is always 1/2 times everything inside to the negative 1/2 times the derivative of what's inside. The derivative of 1 is 0. The derivative of negative x squared, that's just over a squared. So that's just, let's see, negative 2x over a squared. Okay, did I do that right? So negative derivative of what's inside. So derivative of x squared is 2x. It's negative over a squared. Yep, I think I did that right. Okay, and we set that equal to 0. Okay, this is kind of a mess. Let's hope it simplifies, and I think it will. Let's see, this is negative because it's negative 2x, and this is a square root in the bottom, so I'm going to rewrite this. I'm going to put this on the other side. So I have 4b times the square root of 1 minus x squared over a squared equals this stuff. And see, it's just on the top we have 4bx, so 4bx, and then we have a 2x, and remember I put it on the other side so the negative went away. On the bottom we have this 2 and that a squared, so 2a squared, and then we have this square root because it's negative 1/2, so square root of 1 minus x squared over a squared. Okay, the 4b's cancel, hooray. 4b's cancel. If I multiply both sides by 1 minus x squared over a squared, then this cancels, and then I just get 1 minus x squared over a squared here. So that's not so bad. So let's do that. So we have 1 minus x squared over a squared equals, here let's see, the 2's cancel. I have an x squared in the top. This is gone. I have an x squared in the top, and I have that a squared left in the bottom. So equals x squared over a squared. Wow, look at that. It looks so complicated, and it simplifies down. Let me check I did that right. We have an x and an x, so x squared. This, we multiply both sides by that, so it's over here, just those square roots. Yeah, okay. Now, let's put this x squared over here. So now we have 1 is equal to, we add x squared, we have 2 of those, so 2 x squareds over a squareds. Right, add this to that side, now we have 2 of them. Okay, I'm going to try to finish my math right here, so I have to do another piece of paper. I'm looking for x. So put that over there. So x squared is equal to a squared over 2. Right, multiply both sides by a squared over 2, then these cancel. Yep, that's right. Or x is equal to a divided by the square root of 2. Okay, that is the x value that makes our area the biggest. Now the y value is just this. We got to plug this x into here and figure out the y value. So I'm going to do that right below that here. So let's see. Okay, I'll just do it back up here. So the y value then is b times the square root of 1 minus x squared over a squared. X squared is a squared over 2. That's what x squared is, right? Because x is this, x squared is a squared over 2. And then times 1 over a squared. Well, the a squareds cancel. So that's equal to 1 minus 1/2. Square root of 1 minus 1/2, which is b times the square root of 1/2, which is just b over root 2. So that's what our y is. So we figured out that the y value is b over root 2, x is b over root 2. So they want to know what the area is, right? What is the biggest area? So their area is this, 4xb times the square root of 1 minus x squared over a squared. So all we got to do now, oh, and we know the square root of, no, sorry, our area is just 4xy. This is the easy form. The area is 4xy. So finally, I'll put our final answer here. The area is 4 times x, which is a over root 2, times y, which is b over root 2, which is 4ab over 2. That's 4ab divided by root 2 times root 2 is 2, which that's just 2ab. So it's 2ab. And that's our final answer, which was a lot of work. And these things can be a lot of work, right? Took a whole page of paper, and you just have to expect that. There's going to be a lot of algebra. The derivatives aren't hard, but lots of places to go wrong. And that's just the way these things are. So you have to get good at that. Let's see. Numbers 19, 21, and 23 are all kind of tricky. I'll just kind of briefly go over those so you know what's going on. and then you can finish them on your own. That's the challenge of doing these, but let's look at number 19. And again, the answer is in the back, which is nice. So 19 says, a Norman window is the shape of a rectangle surmounted by a semicircle. Okay, so here's what our window looks like. We have a window or rectangle, and we have a half of a circle on top. Okay, semicircle is half a circle. Okay, and they say if the perimeter of the window is 30 feet, find the dimensions of the window so the greatest possible light is admitted. You want the most glass possible, the biggest area possible. So, and the perimeter is 30 feet. Okay, so what we need to know then is, what is the perimeter? So we have to label things. So as always, let's call this thing here A, the height, let's call that B, and then we have a circle here, half of a circle, let's call that R, because that's the radius of our circle. So what is the formula for the perimeter? Well, it's 2A plus 1B, right? Because this one, then we have a circle here. So the perimeter is 2A, because this is A, plus B, plus half of a circle of radius r. Circumference of a circle is 2 pi r, but we have only half of it. So that's just 2 pi r times 1/2 is pi r. So plus pi times r. Okay, that is our perimeter. Oh, and that's equal to 30. Equal to 30. Now, here's the other thing. The radius, if this is the radius, this is also the radius. So the radius is equal to half of b, right? Yeah, I think that's right. Or 2r equals b. So b is equal to 2r. So we can get rid of either the b or the r here. Okay, whichever one we like. Since b is 2r, we might as well get rid of the b. So the perimeter is 2a plus 2r plus pi r. Or we can write that as 2a plus 2 plus pi, and you can make that 5.14 if you like and round off times r. So we can say 2 plus 5 is, yeah, 5.14. Okay, that's our perimeter. Now we need a formula for the area. So the area is a rectangle, AB, oops, but b is 2r. Might as well write that now. So AB, which a times 2r, AB, because b is 2r, plus the area half of a circle, so that's 1/2 of pi r squared. Okay, now we have two variables here. We have an r and an a, and we can use this equation to get rid of one of them, and this is equal to 30. What I would do is solve for a, plug it into here, and then you take the derivative with respect to a, so you go dA, dA, it's kind of weird, but d big A, d little a, set that equal to 0, and the tricky part now is again solving for a here, and then plugging it into here. It's going to be a mess, right, because we have this 2 pi plus pi r, then you're only going to have, oh wait, no, then we're going to have r's if we do that, so it's going to be dA, dr. Yeah, we're going to replace this a with this a. So solve for a, plug it into there, you can have this 30 and a bunch of stuff and this bunch of algebra, and then you can figure that out. But that's, I'll let you guys do that. That's the way you do these. 21 is a piece of wire cut into two pieces. One is a square, the other is an equilateral triangle. Okay, so here we have a square, an equilateral triangle. As always, you got to label the sides. Squares, they're both the same, right? So A. Rectangle, let's call it's an equilateral, so they're all B. So B. And the length, so that would be is 10. You have 10 feet or whatever of wire, doesn't matter what unit it is, they say 10 meters. So let's see, that would be 4 A's, right? So 4 A's all the way around the square, and then 3 B's is equal to 10. Okay, we have one equation, and now they're going to say something about the area. So it says, how should the wire be cut so the total area is a maximum and a minimum? Okay, so the total area then is a squared plus, let's see, area of a triangle is 1/2 base times height. The height is this, and if it's an equilateral triangle, then I know that let's see, if this is b and this side is 1/2 b, we can do the quadratic formula, the Pythagorean theorem. So we have this squared plus this squared plus this squared, our height, is equal to b squared. So h squared plus 1/2 b, right, because this side of our right triangle is half of b squared, is equal to b squared. And we can solve for h, and let's just do that really quick. So h squared is equal to b squared minus 1/4 b squared, which is 3/4 b squared. Take the square root. H is equal to square root of 3 over 2. Let's see, square root of 3, square root of 4 is 2 times b. Okay, so 1/2 base. The base is b. Yep, 1/2 base. So that works out well, right? Calling the base b. I just got lucky there. Times the height, which is that, which is root 3 over 2b. Okay, so like before, we solve for one of them here, a or b here, plug it in, so we only have b's maybe, take the derivative, set equal to 0, and you figure these things out. And 23 is similar, just more geometry. I'll see if you can figure that one out on your own. This is good stuff. And again, these are called optimization problems. We're finding the right dimensions to optimize the situation, to have this biggest area to the smallest area, all that kind of stuff. So, and there's a lot of algebra. Usually the derivatives, the calculus usually is not hard. The derivatives are easier. It's just setting up the problem, because they're all word problems and that can get tricky. Okay, so good luck doing these. This is our last topic in Calc 1. And then there's some more in the final exams, 3 more problems in each final exam. They'll always have one of these that we need to get good at doing. And then we'll be done with Calc 1. Okay, thanks for listening.